the enemy tanks have stopped.
Why?
Why waste precious tanks when they can pick us off from the air like fish in a barrel?
There are 400,000 men on this beach.
He's coming back round. He's coming back round!
Where are we going? Dunkirk.
I'm not going back.
There's no hiding from this sun. We have a job to do.
If we go there, we'll die.
You can practically see it from here.
What?
Home.
Developers from the British Expeditionary Force. You are here in Dunkirk and you are surrounded by the enemy. There is only one way to survive: the sea evacuation to your home country. It is only 80 kilometers, but the bay is too shallow for our warships and we don't have too much of them. It's time for Operation Dynamo. You need to use little ships of Dunkirk. About 850 private boats. They are distributed and available special for you via Boats API. Please use them in a responsible and resilient way. Good luck. My name is Tomasz Skowroński, and today I will say more about resilience patterns, how to use them not only in sea evacuation case, but in everyday development. Let's start with rate time limiter. Do you know this feeling when you stay in long queue, very long one, like this one, and ask, why does it happen always only for me? The answer is time limiter. What timeout is, everybody knows, but what is time limiter? You can think about it as if it were a timeout factor. With Resilience 4J, without annotations, without reflection or aspect-oriented programming, you can add, configure, and measure timeout to any future supplier. Now it's time for rate limiter. This time it is also about time, but here time has different meaning. Because rate limiter limits not the duration of execution, but the number of executions in the same time period. So let's see how it works on the example. In Resilience 4J, you can configure all components in a similar way. That means you can retrieve them for the register or create using builder. You can use custom, that means default values, but you shouldn't do it even if you know default values because of readability. So what you need is configuration of component like this. I will talk more about parameters later. The name, it will be, of course, it should be better. It will be used for metrics, and that is all. Now you need to use your component with your method. In the case, this method is implementation of runnable, but in contrast to Hystrix, you don't need extend Hystrix command class. You can just provide runnable, callable, function, supplier, consumer, future, almost every standard Java interface. In this case, we decorate our method evacuate with created just before rate limiter. So what this limiter do? It is configured in this case in this way that we limit only for 1 executions for each 2 seconds time window. This time window isn't movable. So it shouldn't be surprised then if we call it once and second time, the second call is rejected and not permitted. Resilience 4J, in contrast to Hystrix, which had 3 dependencies and each of them had own dependencies, Resilience 4J has only 1 dependency. It is waiver, known previously as a Java slang. And you can, but you don't need to use it because waiver isn't part of public API of Resilience 4J. But it is good to use, for example, try. Try is like optional, but in case of failure, it isn't empty. It contains the exception, the reason of the failure. So in this test, I use try just to prevent code like this. We don't need no try and catch. Let's use try. So in the second case, there is very similar configuration, but the second call was permitted. Why? Because sometimes it is better to delay executions. Maybe there will be place for this execution in next time period, than retry. And retry is another resilience pattern. Probably it is the most popular, the simplest one, and the most dangerous. Why? Because you can configure just a few things in retry. First is the number of attempts, what is obvious. The second is interval function. Defaultly, it is constant time, but you should probably replace it with some provided by Resilience 4J function like exponential backoff or maybe some randomized. You can write custom function. It is a function of number of attempts, current attempt. And some conditionals. You can make your retry more intelligent, smarter. That means you can define exceptions. You can define function of exception or function on result. And for example, say, my retry should work only for server error exceptions. That means if status of response is higher than 500 or equal, it should be retried, not if it is bad request 400, 404, etc. The next pattern, my favorite one, is Ballcut. Let's imagine this situation. 1 boat, 20 people, and only 4 paddles this summer. And now for people with less imagination, just see how it looks in our code. We have here 2 methods. Paddle now, where we access our paddles resource pool, use them for 100 millis, and return to the pool. And the second method, everybody in the boat, where we create 20 threads and start them at the same moment. And let's look how it will work in the first naive scenario without any limitations. There are 20 different threads. That means 20 of the soldiers try to use 4 paddles at the same moment. So it shouldn't be surprised that the number of available paddles on the right is sometimes below 0. What doesn't make sense because it should be between 0 and 4. OK, let's synchronize our paddle now method and look what happened. Now you can see that there are still 20 different threads, even there are only 4 paddles. What is more, some of the threads try to sleep. We shouldn't do it in the boat full of 19 unknown people. And the number of available paddles is always 3. Why? Because we add synchronization, and we can use only one paddle now at the same moment. But so it doesn't make sense because we have 4 of them. So let's add thread pool Ballcut. Like in Hystrix, Resilience 4J provides 2 kinds of bulkhead. That means they have different isolation strategies, thread pool based and semaphore based. So we can use first of them here. and limit the number of threads to number of paddles. Let's see what happened. Even we created 20 different threads, only 4 of them were permitted. You can see that there are only 4 different threads in the logs, and the number of available paddles is never below 0, what is good, but there are still some unnecessary executions. Why? Because of implementation thread pool, it require queue, and the minimal size is 1. So even if we decrease this size of queue to 1, there still will be 1 unnecessary call. But if we use semaphore-based bulkhead, it is the answer for our problem. Even there are 20 threads, 20 soldiers in the boat, only 4 of them can use 4 paddles. So we can think about Ballcut as if it were some kind of pool limitation. And fallback. What fallback is? Some example like on the picture. Let's imagine that sometimes it is better to receive any boat, even it can't swim, than nothing. It is better to receive any boat than a server exception. Maybe some more realistic example. Let's imagine you are HBO Go and your recommendation service doesn't work. Then nothing works. Okay, maybe it wasn't best resilience example, so let's try again. Let's imagine you are Netflix and your recommendation service doesn't work. Then, if you are a client of this service, you can use fallback and display, for example, the list of the most popular movies, or even empty list as a fallback will be better than server exception. I will show an example of this pattern and component and show a fine decorator. What is fine? It is just a Java library similar to retrofit, when you can create HTTP client from Java interface. So what you need is simple Java interface where you have a definition of your endpoints, like here. There is no implementation. It is generated by retrofit or fine. And with fine, you can build your HTTP client. You don't need more REST template or something like this. And if you use Resilience4j extension, you can add also some resilience patterns like circuit breaker, fallback, or rate limiter. And for example, our fallback here is just an alternative implementation of this interface. That means it is better sometimes to receive empty list instead of exception, or some dummy boat instead of exception or null. And there was also condition. That means we want this fallback only when it is a server fault, not if it is a bad request. And now we can use this. So in this test, our server always responds with respond with error. So if we try to find the boat which doesn't exist, -1, we will receive, even there is a bad response from server, we will receive our default dummy boat. It is example of fallback. Let's look here that there is no wrapping, no decorating, because we don't need now decorate our getBoat method. Our all HTTP client, our all HTTP API client is decorated with circuit breaker and this fallback. There are still, of course, more extensions. So if you don't want to use functions or decorators or builder, you can still, and you prefer annotations, aspect-oriented programming, reflections, you can still use your Spring annotations. The same if you use a reactive operator, you can use operators, you can use extension for Spring Reactor or RxJava. And Resilience4j doesn't provide Hystrix dashboard, what it makes sense. But because each component emits metrics, you can simply connect them with your favorite metrics library. And circuit breaker time. If you heard about Hystrix, you must heard about circuit breaker. Let's look at the Resilience4j logo. But not this one. Hystrix is dead. You should know it. Let's look at the Resilience4j logo and just remember 3 words: closed, open, and half open. There are 3 states in each circuit breaker. Default one is closed. How it works in practice? So our server in this test will always respond with errors. There is some circuit breaker definition. We also capture events emitted by our circuit breaker, because each component not only provides metrics but also emits events. And we try to get our bots by API via circuit breaker. There will be 10 calls to our API, some break, and again 4 calls. Let's see what happens. First 4 calls will end with error because our server doesn't work. Great. After 4 calls, our circuit breaker has enough knowledge to check should it switch to a different state or no. Why for? Because of buffer size in closed state, and circuit breaker contains here history of your calls. That means only successors of failures knowledge. And if it is failures, the number of failures is bigger than threshold, default one is half, it switched to closed state. And when circuit breaker is in closed state, it doesn't permit to more calls. In closed state, sorry, in open state, our backend is closed. And after some break, our circuit breaker can verify maybe it's time to check. Maybe backend is working now. And Hystrix defaultly allow to one check. But in Resilience4j we can configure the number of size in the number of buffer in open state, and there is configure 2. So 2 calls are permitted, but because after 2 calls there is still more errors than successes, our circuit breaker back to open state, and no more calls are permitted until next verification. So at the result, you can see that even there were 14 calls to our circuit breaker, only 6 of them hit our backend. It is good, because if it doesn't work, it doesn't make sense to check it or retry again. So our server has had time to be restarted. There was time to load balancing, etc. So you can think about circuit breaker as if it were a failures cache, because it limits potentially failing executions. Of course, there is a normal cache, traditional cache decorator also in Hystrix. It is just a metaphor. Failures cache is circuit breaker. So you can think that resilience patterns aren't complex. Of course, the Dunkirk evacuation, which took 8 days, was more hard and difficult, especially because of fighters and boomers. Patterns are simple, because the question isn't how they work, but how to connect them and when to use them in existing system. What is more, there are more patterns, and not only of them best match with base code. What I showed were resilience patterns, which great matches to your code, but there are higher layers. For example, using containers, you can limit not only threads, but also memory. You can also apply resilience patterns in API gateway, service mesh, or even in cloud platform like health check or load balancing. So it should be just a beginning of your resilience adventure. And what should you remember after this talk? First, don't apply every pattern, and not because it is simple and you can add more decorators, more layers, but because it doesn't make sense to use all of them, and you shouldn't connect them in wrong order. Let's imagine what happened if you use retry and circuit breaker in wrong order. It doesn't make sense. Don't decorate everything, not only because you can use annotations, but because sometimes it is good to know when something doesn't work, and fail fast is also often better than fail safe. And use metrics, not only for colorful dashboard, but first, you need, when your system doesn't work, if you have fallbacks, it isn't clear because you don't see it in UI. And what is more, you need metrics just for your configuration tuning. How to configure circuit breaker, you need to measure it. And even my examples were related to HTTP circuit. That doesn't mean that resilience 4J or even resilience components are dedicated for network. You can apply them anywhere when the executions is unpredictable. That means file system operations, network operations, everything will depend on time or threads and can end with a timeout or with unexpected result. Potentially, it is good to think about resilience in this case. So that is all from me. Thank you for your attention. Forget about Agile, just be resilient. Thank you.